Okay, looking at exercise 7-8. We're going to take a look at our reuse, repurpose. Reminds me I didn't do the limit dimension on the previous, but that's okay. We can correct that real quick, and then we'll go on to save some of the save as options. So looking at these geometries, I mentioned in the previous video that at some point I may want to change the whole wizard item from a through hole to a counterbore. And looking at these geometries, they share a lot of similarities. Right? We don't have the our third or our fourth hole up here. We have a relief, but it's on the bolt circle, and we have a notch going through. So I can reuse that that geometry as we go through. So on the revolve now, I'm going to catch up with this one real quick. We're going to right click and edit the sketch, and the 1498 is going to get a bilateral and plus 002. Oh, I did bilateral. I was thinking limit, or said limit and thinking bilateral. Alright, so that gives me the upper and lower bounds. We go ahead and hit OK, save it. And then now we have to make a decision as our save as. We want to be careful if this has already been inserted into an assembly. The naming, the external references, those can present some additional problems. So watch for the warnings and take it kind of slow. So I'm going to do a save as, and this becomes item 7-8. And I'm just going to shorten it to bushing. Shouldn't matter if I leave it as the revolve. I don't really need that description, but it'll kind of tie it back together. So we're going to do the save as. I want to do a save as copy and open. All right, so these are how it's being managed in memory. We have the previous, and I believe I hit save. If not, I can go back and change it again. But I want to save as, copy, and open. And what that's going to do is the file that is on the hard drive, it's going to write this new name to the hard drive, and then it's also going to make sure it's open in our current SolidWorks session. So when I look at the open in SolidWorks, both the 7.5 is current, and then the 7.8 is now the one that's active. All right, and if I had a little more screen space, oh, there we go. Just hover over it, and it's telling me that this is the active window. All right, so we're going to start by modifying our dimensions. So if I expand out and I double click on the sketch, I can see all those dimensions, but it's going to be quite a bit of noise. So I'm just going to right click and edit the sketch. We'll find some of these dimensions. Alright, so the inside, probably go with the inside to the outside. So 1.372 plus 3 minus nothing. So in that case, let's take a look at this. This is a bilateral dimension. 1.372 to 1.375. So this would be maximum material condition, making it a little bit oversized to get to the upper limit. So in this case, we'll go to the tolerance, switch it to bilateral, plus dimension is 0.003, and we end up with our number. I can overwrite 1.372, and that adjusts, and the sketch adjusts accordingly. So the parameter in the property manager has the same effect as double clicking and changing the value here. So it was just easier since we were over here setting the tolerances anyway to go ahead and include it. So that one was not marked for the drawing. So I'm going to go ahead and mark it. And again, my reasoning for marking, not marking dimensions is that you design for convenience and then you detail for manufacturing. So the process by which I go through, we're reproducing existing dimensions here. In a normal mechanical design engineering project, you are making this up as you go. Your imagination, your experience is what's driving these dimensions and these tolerances. So that being the case, there's no set way that you have to create these models. And that being the case, you're going to end up with a variety of strategies that are not the best for manufacturing. So 4.75 for our diameter, 0.62 for the lip, and here pretty quick we're going to start paying attention to this third decimal place. 2.62. All right, so these would be 5/8, 2.625, 0.625, 2.625 for our dimensions. Let's see, the outer is 2 inches. So from 2 inches, let's fly this in and we'll double check. 2 inches, that's the width. That was our tolerance. Not ready for that just yet. All right, I think we got it. So with the change of a few numbers, we go ahead and set the revolve. And we're expecting, we didn't end up with any really bizarre errors. Turns out there's no fillets and rounds on this one. All right, so the fillets would be the over, the rounds would be the interior unders. When you see that that call out, so this one just doesn't have any. So I want to go back and right click, but let's take a quick look at what's happening with the two sketches. So the whole wizard always generates two sketches. Sketch 2 is the positional location of the geometry. Sketch, well, the second sketch in the list is the revolve. So where this intersects the point, that gives the location, and then this is how the geometry, we're going to see this go from just a rectangle, we're going to see it go over to kind of a T-shape to make the T-shape, L-shape to make the counterbore. All right, so to modify this, we're going to edit 3 times 0.375. So chances are this is going to be a counterbore for a 5/16. And as a matter of course, we're going to stay with the socket head cap screw. All right, that's going to be just a good safe bet. So it uses a hex key to tighten, and we have the loose fit, and I want to see the custom sizing. So 3437. And what is that? We go to 9/16, 17/64 or something to get to 531, or 17/30 seconds to get to a 531 number. All right. And then to a depth of 300, so we're kind of in that rounding range. Okay, so as usual, be careful when you start making adjustments to the custom sizing. We're doing this to match an existing standard, but if I know that I'm using a 5/16 socketed cap screw, I'm probably going to stay with the 11/30 seconds, the 17/30 seconds, and the 5/16 bore. 0.3. And then we'll go back to the positions. We're going to be missing one position, so highlighting the point, hitting delete. Everything else stays in pretty good shape. And then my bore, or my base circle, becomes 3.38. Alright, we'll just check our dimensions here real quick. So 375 is the through hole, 0.75 is the step, or the step diameter, and the 300 is the step depth, and we have a total of 3 items. So go ahead and accept. Alright, now we need the notch. Alright, so for the notch we have this kind of rectangular shape, and there actually was a fillet in there, but we'll survive putting in a new one. So we can use that previous sketch in maybe, so 1.24 for our height and 1.12 for the width. So on the front plane, we'll open up a sketch. I'm going to go into the rectangle and select the origin, Control select the line, go to midpoint. We're right here at smart dimensions, so I'll pick the smart dimension, 1.12, 1.24. Gives us the step. Now if we want to use the contour and region, we can just go up, use our continuous arc to go into tangent, look for an inference line, bring it back down, and set. So the center point and the origin can be vertical. I could also draw a center line and set some symmetry. What I want to check for, well, these are growing and shrinking pretty decent. They're not doing anything strange. So radius of 0.24. And it is on the bolt circle for the counterbore. So if I come over, right click on sketch 2, I know that that is where I had that geometry. I can select the center point and control select the circle, even though it's in another sketch, make that coincident, and now it will drive or be driven off of what the counterbore. So if I find that I have to make an adjustment for that bolt circle, it will also set the relief. Alright, so I jumped out of the sketch somewhere along the line there. So we're going to highlight the sketch. I don't need to go back in to make this work. I can go ahead with an extrude cut through all, and then just be aware that the selected contours comes up and it's going to be contours and regions. So region, if I rotate over, I'll be able to see those regions a little bit better. And cannot locate the end of the feature. That means we need to reverse the direction. Now I see the preview going through the part. That makes a lot more sense. Last is to put the 1/8 inch fillets into the corner. So I'll pre-select, try and get my edges, not my faces. There we go. And 0.12. All right, quick look at the geometry, but just recognizing that I have similar profile, similar geometry to the previous part allows me to reuse and repurpose that geometry, so I didn't have to start from scratch. Not that it would have been that big of a deal to create the L shape and the center line and create that first revolve, but it did save 3-5 minutes somewhere in there of creating that geometry. Alright, so we need to save this, and then we can close, and I'll save all just to make sure. Do a quick double check, and so that one had the tolerance on it, but I did not mark it for drawing. So picking on it, that should take care of it. We'll go ahead and close those out, call it good.